In this example, we are going to calculate how much reactant will be in excess. I have a balanced equation here of phosphoric acid being added to 3 moles of sodium hydroxide to form sodium phosphate and water, 3 moles of water to be more precise. The question reads, if 1.75 moles of phosphoric acid reacts with 5 moles of sodium hydroxide to form sodium phosphate and water, how much reactant will be in excess? So in this problem, one of these reactants is a limiting reactant, which means it will run out first. One of these reactants is the excess reactants, which means there will be left over of it after the reaction is over. So when we calculate which one is the limiting or which one is the excess, we're going to start with one of these numbers, and it doesn't matter what we start off with, but I usually start with the first number. So if you have 1.75 moles of phosphoric acid, then here's the calculation that we will do to calculate how much NaOH is needed. I take the number of phosphoric acid. I'm going to do a mole to mole ratio from the coefficients of 3. For every 3 moles of NaOH, there's 1 mole of phosphoric acid. And I chose to put the moles of phosphoric acid in the denominator because I need moles of phosphoric acid to cancel out with moles of phosphoric acid. I can type in my calculator 1.75 times 3 to get 5.25 moles of sodium hydroxide. So this number basically represents how much sodium hydroxide is needed if you have 1.75 moles of phosphoric acid. We're going to compare this to the amount of sodium hydroxide that's given to us in the problem. We start off with 5 moles of sodium hydroxide and we ask ourselves, do we have enough? We have 5 moles available, but we need 5.25 moles, and we do not have enough. Therefore, NaOH is the limiting reactant. Now, here's the problem. Since we didn't do a calculation to directly identify the excess reactant, we're actually going to have to do the same exact calculation, but for the other substance. So here is the same type of calculation, but instead of starting with phosphoric acid, we're going to start with the sodium hydroxide because we need to be able to calculate how much how much phosphoric acid is needed. So here's the mole to mole ratio. Notice that these equations are flipped around because now we're starting with a new substance. We're starting off with moles of NaOH, and we need moles of NaOH to cancel out diagonally. I can type in the calculator 5 divided by 3, and we get 1.67 moles of phosphoric acid. This is how much is needed versus how much is available. So there's 1.75 moles available of phosphoric acid, but you only need 1.67. So to calculate the amount of reactant that will be in excess, to calculate how much is going to be left over, think about it. We have 1.75 moles available, but we only need 1.67. It's just a subtraction problem from here. 1.75 moles minus 1.67 moles will give us how much leftover phosphoric acid there will be.